Hey everyone, today I want to talk to you about mole ratios. How do we use them and just kind of how they work? So, for a mole ratio, the first thing you need is a balanced chemical equation. So, let's say our chemical equation was something like 4Fe plus 3O2 becomes 2Fe2O3. Now, in this reaction, we have coefficients, okay? And these coefficients represent how many moles of each respective substance are participating in the reaction. So, in this reaction, we have 4 moles of iron reacting with 3 moles of oxygen to form 2 moles of iron oxide. Now, we can compare two of these substances and compare the number of moles that are participating and create what's called a mole ratio. So let me show you kind of how this works. Let's say we were starting with 7 moles of iron, and we're trying to find how many moles of oxygen we would need to react. Okay? We can solve this using the mole ratio and just a basic unit conversion. So we're going to start this out the same way we start out all of our problems. We write down what we were given, 7 moles of iron. Set up our chart. In the bottom right, we copy the unit from the given. So on the bottom right, I'm going to put moles of iron. On the top right, I'm going to put the unit I'm trying to get. I'm trying to find moles of oxygen. Let's make that, try and make that look a little nicer. Okay. Now I need to know what numbers go here. This is where the mole ratio comes into play. Because what I'm going to do is I'm going to take the coefficients and put them in the matching spots with their units. So, for instance, on the top, you see how I have O2? I'm going to put the coefficient from O2 in this blank spot. So I'm going to put a 3 right there. On the bottom, I'm talking about moles of iron. So I'm going to put the coefficient of iron in that bottom spot. Put a 4. I'm going to cancel out my units. Now I have the unit that I'm looking for. I have moles of O2. So I know I don't need any additional steps. I'm in the right spot. I just have to solve the math problem. So we're going to squish this into one big fraction. On the top, I have 7 times 3. On the bottom, I just have a 4. So let's go ahead and solve this up. Let me pull out my handy dandy calculator. 7 times 3 equals divided by 4. The answer is 5.25 moles of iron. Oops, sorry. My mistake. Moles of oxygen. Ooh, that would have been embarrassing. Okay, so the unit that we had left over just gets carried over and put at the end. Okay, let's try another one. But let's make it a little bit more complicated this time. Okay, because what happens if I don't have a balanced chemical equation? Let's say I have something like BF3 plus H2 becomes 2B plus, let's just put a B, plus HF. Okay, so let's balance this. Okay, because mole ratio only works if you have a balanced chemical equation. So let's balance it out. Let's list what elements we've got. We've got boron, we've got fluorine, and we've got hydrogen. Okay, reactants and products. Let's count them up. 1 boron, 3 fluorine, 2 hydrogens on the left, and then 1 of each on the right. Okay. So the strategy is whatever is by itself, we want to kind of save that for last. So we have boron and hydrogen by themselves. So let's try and save those for last. Let's balance fluorine first. I've got 3 fluorine on the left and 1 on the right. So let's try making this a 3 right here. That changes fluorine and hydrogen. There's now 3 fluorine and 3 hydrogens. But see, I have 2 hydrogens on the left and 3 on the right. 2 does not go into 3 evenly. So I need to double the amount of hydrofluoric acid, HF. So let's make that a 6. Change this up right here. We now have 6 fluorines and 6 hydrogens. Now we can balance hydrogen because 2 does go into 6 evenly. Let's put a 3 right here. Clean up what I did before. I now have 6 hydrogens. My fluorine's no longer balanced because of what I did before. So let's fix that. Each BF3 gets me 3 fluorines, so I need 2 of those to get to 6. But that also changes the amount of boron. I now have 2 borons. Now, because I left boron by itself on the right-hand side, I can just change this and it'll be balanced. So there's 2 borons on the left, 1 on the right. So let's make this a 2. And now we are balanced. Okay? So we've got a balanced chemical equation. And let's say we have 8.92 moles of HF, and we're trying to find the amount of moles of BF3 that were used. Okay, so mole ratio works no matter what side it's on. You can compare two substances on the same side, or you can compare substances on opposite sides of the arrow. So let's set up our chart. 8.92 moles HF copy our unit from the top left to the bottom right. And let's put the unit that we want. We want moles BF3. Now we need the mole ratio. On the top, we're talking about BF3. BF3's coefficient is a 2, so I'm going to put a 2 on the top. HF has a coefficient of 6, so I'm going to put a 6 on the bottom. Now, we're going to cancel out our units. We're at the unit we want, so we can squish it together and solve. But the other thing that we could do, and this is only if you're comfortable with it, if you're not, you don't have to do this. Plugging it into a calculator will still get you the same answer. But you see 2 over 6, we can actually reduce that. We can cross out the 2 and make that a 1, and cross out the 6 and make that a 3. So see how we're dividing both the top and the bottom by 2? Anything we do to the top, we do to the bottom, and it is the same. So 2/6 is the same as 1/3. But this makes the problem a little bit easier because now when I smush it together, 8.2 or 8.92 times 1, that's just 8.92. And on the bottom, we just have a 3. So, again, let's get out our calculator. Our answer is 2.97 moles BF3.